Okay, folks, so here it is. I'm trying to give you the final truth about PID. Okay, so why am I doing this video? More and more often I see questions popping up on the internet. What is PID? How can I understand it? What relevance does it have? And for me, I do quadrocopters as a passion. And as a profession, I teach autopilot, so there is a good connection for that. And now, to give you the truth right ahead, there is no good connection between your quadrocopter and PID itself. So if this is all you're looking for to figure out, okay, which part of my quadrocopter is the P part, which is the I part, which is the D part, this video cannot tell you how that works. Now, what I can tell you is what is PID, and I'm trying to do that. And let's get started with a little video here. I found it on the internet, and somebody is trying to figure out some settings on his quadcopter. So this is what we're looking at. And important for me, if you look down here, this is where you can see his stick movements. So right now his stick is in the middle, and you will see during the video that he moves the stick up and the quadrocopter starts to rotate, and that's relevant for us. So let's check this out first, and then I'll talk about it.
Settings, I raised my settings to do this. So we've got it all set up. Let's go ahead and arm it.
Okay, so there is the quadrocopter, and now watch his stick settings.
Spin it around.
And what I want you to notice is that for a constant stick setting, you see a constant rate of rotation for the quadcopter. I'll start the video again and just watch it. As long as he has his stick at one given position, the quadrocopter will rotate with a steady rate.
And really we should do this about the level we're at.
And I'll do this again. Hang on a second. And here goes once again. A steady rate. And once again. Oh, okay, I hope you were able to see that. So as long as we have a steady input, there will be a steady rate of turn with the quadrocopter. Now let's move over here to this little program that I have. And you can see the controller input, the transmitter. You see the quadrocopter, and right here I've got the roll rate. So that is the quadrocopter turning around its roll axis. You would actually have to do this around all three axes, so it would be roll, pitch, and yaw. Now for the purpose of this video I will stick to roll, and that should make everything hopefully a little bit clearer for you. So we've got my transmitter and we've got the quadrocopter, and I'm plotting the roll rate. Now how does this work? I just this a little bit. I will run a simulation and we will have a look at it. Right now, right here is my plot. So you can see the stick is in the middle position, then he moves the stick, and this is actually the roll rate of the quadrocopter. You see that it will go to a constant roll rate until he moves the stick again, and it will drop back to the first roll rate, which in the video is 0. So you see stick input, quadrocopter has a constant roll rate, and stick back to neutral, and the quadrocopter follows that command and also goes to neutral back. So looks good, doesn't it? Okay, let me do one more thing. Let me connect. Oh yeah, I need to do something first. If we talk about this in scientific terms, unfortunately we're not talking about a transmitter. We have some simulation function that will simulate the stick input, and we will have another simulation entity that is doing the roll rate for the quadrocopter, and back here we have our plots. So you're basically looking at the same things, they just look a little bit more difficult. So there's a stick input, down here is the quadrocopter, and I can show you the roll rate. Now what I want to do right now is I can also take the stick input itself and have a plot of the stick input. So now you see the red line will be the stick input and green will be the roll rate as you've seen before. Let me just start the simulation, and there you go. So you can see The red line is the stick input, and the quadrocopter goes to the constant roll rate, and the stick input drops again, and the quadrocopter follows. Okay, this sounds just normal, isn't it? You use your stick and the quadrocopter will start to roll, and the moment you let go of the stick, it will stop to roll. Now, why are we talking about PID and all this? Now, the trouble with the picture I've shown you so far is that this will only work without any external influence. The moment that something influences our system from the outside, like wind that's actually pushing against the roll rate, the quadrocopter will not be able to follow the stick demand. And let me show you how this looks. I've got my little wind down here, and let's put in some wind influence. I take this off again. So right now what I want to do is have wind be part of what we are doing. So the roll rate of the quadrocopter goes into this combined wind plus roll rate. So now wind is influencing, and we put this once again into the plot for the roll rate. Okay, so what I would also like to do is I would like to show you what the stick is in the transmitter is doing once again. So I connect this one also to the plot. Okay, so we've got the stick input going to channel 1 of the plot, and we've got the combined wind plus roll going to channel number 2. And let's see what happens now. So this is a picture from before without any wind, and now I will have the wind added to the whole system, and let's look how it operates. So you can see that the stick actually demands a roll rate, and the quadrocopter is trying to do that, but the wind is so strong that it actually turns the quadrocopter around the other way and continues, and the roll rate will increase the opposite direction. So we have some relatively strong wind, and the quadrocopter cannot follow the stick input at all because he has no chance to do so, because he does not know about his own roll rate. It's not considered in this system. It's an open loop system. And an open loop system, you put something in, and as long as your value is good, the quadrocopter will perform. But in the moment that something different, like wind, changes the system, you get all kinds of results, and you're not able to control it anymore. So that's why we have to go to a closed loop system. Okay, now closed loop systems, this is where PID also comes into play. What do we do in order to get a closed loop system? Let's see here. Take out the plot of the transmitter input to have a little bit more space here, and also make it easier for you to see what I'm doing. Right now here, at this point, we have the green curve, correct? This is what happens due to the wind. Now what we can do is we can use something that compares what we intend to do with what actually happens. So let me see if I can bring this in. So here I've got a component that compares my input. So this is my input, goes into the compare component, and I take a second, a little bit more room here. How about this? Okay, so I take my system, so what happens with the quadrocopter plus wind, and I put it, how did this work? Okay, there we go. So I take the actual real rotation, in this case it would be the green curve, and I compare it to the transmitter command.